Okay, hello everyone. I'm Hong from Intel, and I work mostly on DPDK virtualization. And in this session, I will give a brief update on our effort in DPDK virtualization, some work we have done, and some in progress, and some we can expect in the near future. Okay. I divide this agenda into three categories. The first category is more about production development, which I review it as a good sign because we see more and more customer adoption on DPDK-based applications like OVS DPDK. And they are like nav migration and memory provisioning and deprovisioning. Also like container friendly. DPDK has done a lot of effort on that part. And the second part is performance, which is a hot topic in all times, right? And the third part is kind of important, is the new Virtio 1.1 renewed proposal, which is out there right now. And also during these items, there's more importantly, there's some help needed from the community that will raise a few help needed or call for actions. All right, the first story. Lab migrations, right? So why is this still a problem? Because DPDK already supported this long time ago. The problem statement is that when customer actually want to use it, they say that, right, DPDK, OVS DPDK is very good. We want to use it, but we have existing VMs running. So how can we migrate, lab migrate our existing business from OVS to OVS DPDK, which is one part of the story. And another part of the story is, we already know that there's some accelerators existing. And how can we migrate from software backends like VHOS user or VHOS net to accelerators? That's another part of the story. And so we take a look at the gaps, right? Because, Virtio is a spec. And if the backend just do everything as the spec says, it should be no problem. So we only find the problem when we try to do that. So there are some feature gaps. It happens a lot when I travel from China to Japan or like here. Everything went very well until I brought up my computer and trying to work. Because the plug, right, power plug, it's the same here, the feature bits, right? So when the existing VMs, they negotiate features with VHOS net, and we want to nav migrate them from VHOS net to VHOS user, DPDK, and there are some feature gaps. And on the right-hand side, there are some gaps we identified in the default configurations. I'm not going into details of them. I just list them here. And so they're in our plan to support them so that we can do the lab migration. And also there's another gap, which is not from DPDK's point of view, but it's from orchestration point of view. They have different commands interfaces. So that's another part we need to address. But I'm not going to talk about the details here. So the to-do is quite simple, that we just align the feature bit with the VHOS net as the first step. Okay, the second part is memory hot plug. This comes as somehow also an important feature because it's one good thing about virtualization is you can actually do resource provisioning and deprovisioning easily. We already have Virtio Balloon, which can steal memory from the guest OS and give it back to the host. So why is this still a problem? Well, the problem is, the customer sometimes use huge page to improve performance of virtual machines. And Virtio Balloon does not work there because when Virtio Balloon gave memory pages from the VM back to the host kernel, take a look at it, and see, oh, this page actually from huge page, from a huge page, and they say, oh, it's fine, you keep it, I'm not going to use it anymore. So Virtual Balloon does not work in this scenario. And if we take a look at this chart, the font is quite small, but it shows that QEMU supports the memory hot plug and hot unplug feature. And we have a reference. This is copied from QEMU GitHub. So the problem solved, right? Until we actually try it. And so this is not some fancy features, but it's some bugs or improvement that we identified when trying to move DPDK vHost user virtualization into production. So the DPDK vHost user actually have some inappropriate app behavior when it handles memory region update message from QEMU, that it will unmap all the memory regions and map them again, which will cause problem. Because the driver can still pull those memory regions. So the fix is also quite simple, that we can just fix them in the vHost user. Container friendly. DPDK has put a lot of effort to make it run with container more better, and then we have implemented Virtio user to accelerate the container data path. And so what's container can bring is we have density improvement, and this density and boot time is important to containers. And we also have, from, I don't remember the release number, but we have done something before to improve that. And so if we take a look at this problem statement, first is the memory model. If DPDK is going to support better density, so it have to enable the use of long 1 gigabyte huge page, which means 4K or 2 megabytes. So there are some improvements we need to address to enable that. The first is we have some improvement for Virtio user to address that too many files limitation. And another one is not Virtio user, it's not Virtio or vHost specific, but it's one DPDK related issue right now, the 4K page support with VFLO. It used to work, but currently it's broken somehow, and we also need to fix that to enable this. And so the next is fast boot. Like I heard this conversation about this item quite a lot these days, like yesterday or just in this conference. And the motivation is simple. It's not just for containers, but it can also be for other DPDK-based applications like OVS DPDK. If the user wants to do hot upgrade of OVS DPDK, it sometimes need to reboot OVS, and they would just want to, the downtime to be very, very short. And this table here shows we did some profiling, or to just break down these time cost in the initialization phase of DPDK-based applications. Like the huge page initialization costs more than 300 milliseconds per 1 gigabyte. MBUF initialization, 1 million MBUFs takes more than 300 milliseconds. Well, it depends on the memory socket, actually. And all these numbers, they might not be exactly the same, but they may not change a lot from platform to platform. And the bus probe also takes several hundreds of milliseconds, and device start also. So if we add them together, we can see that for just a simple DPDK application, it takes more than 1 second to boot and until it's usable. And this is this is the time for call for proposal, and we need help from the community to some innovation here actually solve this. So we just list the fact here. And I'm not sure if we have enough time in this session to actually go into details to discuss this, but we just want to bring it up to the community. So, okay. Okay, finally, performance. Performance is always a hot topic in DPDK. And when we say memory copy here, we did not mean the memory copy function or, load and store instructions. What I want to say is we actually mean the real data movement in the hardware, which is the only thing matters. Because if we take a look at the instruction manual, right, the load instruction and store instruction, they take only, a few cycles. But the real penalty comes from cache movement, from, just take an example of Virtio, but this is not specific to a Virtio, but to any data transfer protocols. For any data transfer protocols like Virtio, there's two kinds of overhead. The first is protocol overhead, which is like the ring management index update, this stuff. Another part is going to be, of course, data movement overhead, which is actually when the data transfer from one place to another. And in, common use cases like Virtio, we have front end, which is a Virtio driver, and the back end, which is a vhost driver. And they're usually running on two cores. So actually, this is a core-to-core problem. So when we say memory copy, we actually means data. Yeah, let's look at the test case here, that we have test PMD running on the host, and we have a virtual machine which also runs the test PMD. It has Virtio PMD inside. So the data actually flows from this host core, the host core as L1 cache, to the VM's core. And that's where the penalty really occurs. So we did a lot of optimization in DPDK, and since DPDK version 1607, just release by release, we can see there's huge improvement, especially in this release. We have enabled the batch copy of small packets. These patches are we listed here. There are in a lot of forms, but the principle under it's very simple actually, because it's just like adding other optimization techniques for memory access, which is access them together, access them sequentially, and access them consecutively in instruction level, which means we actually should put these instructions together, not just memory copy, especially for call-to-call, because the call-to-call the latency is so long that if you have one more pipeline store, and you will have more than 100 cycles sometimes, maybe 70, 60 cycles of penalty. So we have done, I think the performance right now looks pretty good, but where's going to be the next breakthrough? And in our opinion, it will come from first is going to be the trade-off. The performance and feature trade-off, it's always a trade-off when we do optimization, right? Because if we're going to implement all the features of Virtio or any other protocols, there are going to be some features that stop us from doing some extreme optimization because we cannot make any assumptions. But if we can actually abstract some use cases that let's look at some features and say, oh, we don't need that in this case. So we can just get rid of it and maybe implement a aggressively optimized implementation. And another part is ring layout evolution. Like we said, there are two kinds of overhead. The data movement overhead, which we have done massive effort on that. And another part is, of course, goes back to the ring layout, the protocol overhead. Let's go to the next page. Red Hat has proposed the Virtio 1.1 ring layout in the community. The link is here. And if you take a look at it, the most significant change is we used to have 3 rings, right? The available ring, the used ring, and the descriptor ring. And now we have only 1 descriptor ring. So 3 rings does not necessarily mean it's bad, but when we say a ring layout is good, is better than another, we actually mean that this ring layout can enable us more optimization techniques for when no matter in what form we implement it, no matter if we implement it in C programming or in other accelerators like PCIe bandwidth utilization efficiency. So this is the performance numbers here right now, which is based on the current proposal. Intel has done a lot of we implement the proposal and inside of DPDK, and the code is out there, which also demonstrates that DPDK is a great place for new technologies. And we also did some proposal based on the analysis on that. And finally, the number looks good. It's to 23% of performance gain. Test setup is PVP, like it shows in this link. And finally, I think it's very important to call for review from the community, from all of you, to actually improve the Virtio 1.1, because it's important that we make it, make it right. Okay. Do you have any questions?
About live migration, I think it's a bit more complex than that, because today we cannot even be sure that we will succeed to migrate from 2 versions of the host user backend, for example. And implementing all the features will not be enough, because we have to manage the past. So I proposed something to support this, but only for the user backend. So maybe we could work together to also support with the kernel backend to ensure migration. Because there is not only the features, you could also have, for example, the number of descriptors that are limited to 1K due to scatter-gather lists in the kernel. But in theory, we could go higher with the host user. So if we want to be able to migrate from user to kernel, etc., we need to have something maybe at management level to ensure migration is possible before initiating the migration.
Yeah, that's correct. And there's more things to do in terms of the whole solution, right? Yeah, that's true. That's where we have the gray, these small items below.
Thank you.
Thanks. Thanks, Joe. Just put it here.
Thank you, Jiang.